Hi there. In this interview, we are going to test how well you actually understand reliability metrics, not just definitions, but how they influence real production decisions. Too many engineers can recite availability percentages, but cannot explain what those numbers mean for customers or the business. I want you to treat this like a real interview. When I ask a question, pause the video. Answer it out loud as if you are in the room. Then listen to the sample answer and compare your thinking. If you find this useful, subscribe so you do not miss the next deep dive interview. Warm-up behavioral questions. Tell me about a time when reliability metrics exposed a problem that no one realized existed. A strong candidate might say, in one of my previous roles, we believed our system was stable because we rarely had full outages. Our uptime dashboard showed over 99.9% availability. But when we started measuring latency percentiles instead of averages, we discovered that during peak traffic, our P95 and P99 latency were significantly higher than we thought. Users were experiencing slow responses, even though the system was technically up. That changed our focus from pure uptime to user experience. We redefined our SLOs around latency thresholds, added auto-scaling improvements, and optimized database queries. That experience taught me that reliability is not just about whether the system is reachable. It is about whether it performs within user expectations. How do you communicate reliability metrics to non-technical stakeholders? A strong candidate might say, I avoid using raw metrics like error rate percentages without context. Instead, I translate them into user impact. For example, instead of saying we had a 0.5% error rate, I might say that 5 out of every 1,000 user requests failed during peak hours. Or I might frame availability in terms of downtime minutes per month. I also connect metrics to business impact, such as revenue loss during degraded performance. The goal is to shift the conversation from technical numbers to risk, customer trust, and business outcomes. That way, leadership understands why investing in reliability improvements matters. Describe a time when you had to push back on a feature release due to reliability concerns. A strong candidate might say, in one situation, a product team wanted to release a new feature ahead of a marketing campaign. Our load tests showed that under projected traffic, our error rate would spike beyond our defined SLO. I presented data showing how much error budget we had already consumed that quarter and explained that releasing under those conditions could cause us to burn through the remaining budget quickly. I proposed either scaling infrastructure first or running a limited rollout. We agreed on a phased release with monitoring gates. The key was grounding the discussion in measurable reliability metrics rather than opinion. Core technical and scenario questions. What reliability metrics actually matter, and how do you decide which ones to track? A strong candidate might think out loud like this. It depends on what the system promises to users. At a high level, availability, latency, error rate, and saturation are foundational. Availability tells us if the service responds. Latency tells us how fast. Error rate tells us how often it fails. Saturation tells us how close we are to resource limits. But I would not track everything blindly. I would start from the user journey. For example, if this is an e-commerce platform, checkout latency and payment success rate are more critical than internal admin APIs. I would define service-level indicators that directly reflect user experience. Then I would align SLOs with realistic targets based on historical performance and business tolerance for risk. Metrics matter only if they influence decisions. Explain the difference between SLIs, SLOs, and SLAs and why they are important. A strong candidate might say, an SLI is the actual measured metric, like the percentage of successful requests over a time window. An SLO is the target we set for that metric, such as 99.9% successful requests over 30 days. An SLA is the contractual agreement, usually with financial penalties, based on those targets. What matters operationally is the SLO, because it guides engineering trade-offs. If we are consistently exceeding our SLO, we may have room to move faster with features. If we are breaching it, we need to slow down and prioritize reliability work. The SLI gives us visibility. The SLO gives us a goal. The SLA introduces external accountability. If your service shows 99.99% availability but users complain constantly, what could be wrong? A strong candidate might reason through this carefully. First, I would question what availability actually measures. If availability is defined as responding with any HTTP status code, even errors might count as available. Or maybe the measurement excludes certain endpoints that users rely on. Another possibility is that the availability window hides short but frequent disruptions. Users feel pain during those moments even if overall uptime looks high. I would also check latency percentiles. A system can be technically up but too slow to be usable. Finally, I would examine whether the metric reflects real user journeys. Synthetic checks might pass while actual user flows fail. This scenario highlights that a single metric never tells the full story. How do you use error budgets in practice? A strong candidate might explain, the error budget is essentially the amount of unreliability we are allowed before breaching our SLO. If our SLO is 99.9% availability over 30 days, that translates into a defined amount of acceptable downtime. In practice, I track how much of that budget we have consumed. If we are burning it too quickly, I recommend slowing releases and focusing on stability improvements. If we have plenty left, we can take more calculated risks, like shipping experimental features. The value of the error budget is that it creates a shared framework between engineering and product. Instead of arguing emotionally about risk, we look at data and make decisions accordingly. When designing metrics for a new service, where do you start? A strong candidate might think step by step. I start with the critical user actions. What must succeed for users to consider the service functional? Then I define measurable indicators around those actions, such as success rate, latency thresholds, and data freshness if applicable. Next, I evaluate resource metrics like CPU, memory, and queue depth to detect saturation. But I treat those as supporting signals, not primary indicators. I also consider failure modes. If the database becomes slow, how will that surface in user metrics? Designing metrics is about connecting infrastructure signals to user experience. I aim for a small set of high-signal metrics rather than a dashboard full of noise. Next, how do you decide the right SLO target for a service instead of just picking 99.9 or 99.99 by default? A strong candidate would not jump straight to a number. They might say something like this: I do not start with the number. I start with the business impact of failure. For example, if this is an internal reporting tool used once a week, 99.5% might be completely acceptable. If it is a payment API handling live transactions, the tolerance for failure is much lower. I would look at historical data first. What has our actual availability been over the last few months? If we are currently at 99.7%, setting a 99.99% SLO overnight is unrealistic and demoralizing. On the other hand, if we are consistently at 99.99% with no effort, maybe we are over-engineering. I also think about cost. Every additional 9 in availability has an exponential cost in architecture complexity, redundancy, and operational overhead. Moving from 99.9 to 99.99% might require multi-region failover, active systems, and much more testing. I would have a discussion with product and leadership about whether the extra reliability justifies the extra cost and engineering effort. So the right SLO is not a vanity metric. It is a negotiated agreement between user expectations, historical performance, and business priorities. You notice that your P99 latency is rising steadily over several weeks, but average latency looks stable. What does that tell you, and how would you investigate? A strong candidate might reason through it carefully. If the average is stable, but P99 is rising, that means most users are fine, but a small percentage are experiencing much worse performance. That is often a sign of tail latency problems. First, I would check whether the increase correlates with traffic growth. Maybe certain instances are becoming saturated under peak load. I would examine resource metrics like CPU, memory, and connection pools to see if there are spikes during those slow requests. Next, I would look at dependency calls. Often P99 latency is driven by slow downstream services or databases. One slow query or timeout can drag the tail significantly. I would also check for uneven load distribution. If one node in a cluster is overloaded while others are idle, that can cause high tail latency. Maybe the load balancer health checks are too permissive. The key insight is that users remember bad experiences. Even if 99% of requests are fast, that 1% can damage trust. So I treat tail latency as a first-class reliability concern, not a statistical anomaly. Let us say your service meets its SLO, but the error budget is being consumed in short, intense bursts during deployments. What would you do? A strong candidate might say this is a classic deployment stability issue. Even if the monthly SLO is technically met, burning error budget in bursts suggests we are introducing instability during releases. First, I would analyze whether errors correlate directly with deployment windows. If yes, I would examine rollout strategy. Are we deploying all instances at once? Are readiness probes misconfigured so traffic hits pods before they are ready? I might propose switching to a rolling update with stricter health checks, or even canary releases, where a small percentage of traffic is routed to the new version first. That way, if there is a regression, we limit impact. There is also a trade-off here. Slower, safer deployments may reduce error spikes but increase time to release. I would quantify how much error budget we are losing per deployment and present that to stakeholders. If deployments are consistently risky, investing in better test coverage and staging parity may give us a higher long-term return than pushing features faster. How would you design reliability metrics for a distributed system with multiple microservices? A strong candidate would avoid saying they would just measure each service individually. They might say something like this. In a distributed system, local reliability does not automatically mean global reliability. Each service could meet its own SLO, but the end-to-end user journey could still fail if multiple small error rates compound. I would define service-level indicators at two levels. First, per-service metrics, such as success rate and latency. Second, end-to-end transaction metrics that measure a full user flow across services. For example, in a checkout process involving inventory, payment, and notification services, I would measure the success rate of the entire checkout transaction. That metric becomes the most meaningful one for users. I would also analyze dependency graphs. If service A depends on B and C, then A's reliability is mathematically limited by the reliability of its dependencies. If each dependency has a 99.9% success rate, the combined path may be lower. That influences how aggressive we need to be with redundancy or fallback logic. The trade-off is metric explosion. If you instrument everything at every layer, you end up with noise. So I focus on high signal indicators that represent user value, then use deeper service metrics for debugging when needed. Imagine leadership wants to publish a public SLA of 99.99% availability. What risks should you raise? A strong candidate would slow down and think before answering. First, I would compare that target to our historical performance. If we have never achieved 99.99% over a sustained period, publishing that SLA introduces legal and financial risk. Second, I would clarify how availability is measured. Is it based on HTTP success codes? Is it based on synthetic checks? The definition must be precise, because customers will measure it too. Third, I would consider dependency risk. If we rely on external vendors, cloud providers, or third-party APIs, our reliability ceiling is partially outside our control. That needs to be factored into any public commitment. Finally, I would discuss operational maturity. Do we have robust monitoring, incident response, redundancy, and disaster recovery in place? A high SLA is not just a metric. It is a promise backed by architecture, processes, and budget. So my role would be to ensure that the SLA is aligned with technical reality and that we understand the consequences of missing it. These are the kinds of conversations that separate engineers who know the terminology from engineers who understand reliability as a system of trade-offs, constraints, and real-world impact. Pressure and judgment. Questions. Your service has technically met its SLO for the quarter. However, there were 3 high-visibility incidents that caused significant customer frustration, even though overall uptime is within target. Leadership is celebrating the SLO achievement. Customers are not. How do you respond? A strong candidate would not dismiss either side. They might say something like this. First, I would acknowledge that SLO compliance does not automatically equal good user experience. SLOs are statistical agreements, but users experience incidents emotionally and individually. 3 major visible outages can damage trust, even if mathematically we are within target. I would analyze whether the SLO definition is aligned with what users care about. For example, maybe our availability metric does not capture partial outages or severe latency spikes that feel like downtime. Then I would present data in context. Yes, we met the SLO, but here is the distribution of impact. Here is how long users were affected. Here is the churn or support ticket spike after those incidents. The goal is not to discredit the SLO. It is to ask whether the metric still represents user value. If not, we adjust the SLI definition or tighten targets. Reliability metrics should evolve as the product matures. They are tools for learning, not shields for avoiding accountability. Next question. You have a limited engineering budget. You can either invest in improving availability from 99.9% to 99.99%, or you can reduce average latency by 40%. You cannot do both this year. How do you decide? A strong candidate would resist answering instantly. I would start by quantifying impact. What does 99.9% mean in absolute downtime? Roughly 8.7 hours per year. Moving to 99.99% reduces that to under an hour. If those downtime hours occur during peak revenue windows, that might justify the investment. On the other hand, reducing latency by 40% might improve conversion rates, user engagement, or operational efficiency every single day. So I would look at business metrics. Revenue sensitivity to downtime versus performance sensitivity. I would also consider competitive positioning. If we are losing customers because the system feels slow, latency improvement might be strategically more important than shaving off rare downtime minutes. I would present both scenarios to stakeholders with estimated cost, risk, and return. Then we align on the choice explicitly. The key is making trade-offs visible instead of pretending we can optimize everything simultaneously. Another scenario. Your error budget is almost exhausted halfway through the month. A major feature launch is scheduled for next week. Product insists it is critical for revenue. Engineering knows the launch is risky. What do? A strong candidate might say this. First, I would quantify the remaining error budget and the historical risk profile of similar launches. If previous releases consumed a predictable percentage of the budget, we can model likely impact. Second, I would facilitate a discussion between product and engineering. The error budget is not a DevOps tool to block progress. It is a shared contract. If we knowingly exceed it, we are consciously trading reliability for revenue. There are options. We could reduce rollout blast radius by using a canary release. We could delay non-critical changes and focus on stability. We could temporarily tighten monitoring thresholds during the launch window. If leadership still decides to proceed despite risk, I would ensure that decision is documented and understood. That way, if reliability degrades, it is seen as an accepted trade-off rather than an unexpected failure. Maturity here means not hiding behind process and not ignoring risk either. It means aligning risk tolerance with business priorities. Final pressure question. A cloud provider outage impacts your system. Technically, your own services are healthy, but users cannot access them because of upstream network or DNS issues. Do you count this against your SLO? A strong candidate would pause. This depends on how the SLO is defined. If our SLO measures user perceived availability, then yes, From the user perspective, we are down. It does not matter that the root cause is external. However, internally, we should separate responsibility from measurement. We might track two metrics. One is overall user availability, which includes third-party dependencies. Another is provider-isolated reliability, which measures what we directly control. This distinction matters for action. If the outage is external, our mitigation strategy might involve multi-region failover, multi-provider DNS, or diversifying dependencies. The key principle is that reliability is end-to-end. Users do not care whose fault it is. They care whether the service works. If you made it this far, I want you to reflect on something. Reliability metrics are deceptively simple words: uptime, latency, error rate. But behind each one is a decision about what matters, what we measure, and what we are willing to sacrifice. Ask yourself which question today made you uncomfortable. Was it negotiating SLO targets, choosing between availability and performance, deciding whether to launch when the error budget is thin? Those moments of discomfort are signals. They show where your intuition still needs sharpening. The best engineers are not the ones who memorize definitions. They are the ones who can sit in ambiguity, quantify trade-offs, and communicate risk calmly under pressure. If this felt like a real interview, that is intentional. Pause the video and think through your own answers again. Speak them out loud. Would you hire yourself based on how you reasoned? In the next interview, we will explore another high-stakes scenario that forces you to balance technical depth with business reality. Subscribe if you want to train like this consistently. The goal is not just to pass interviews, it is to think like a senior engineer when it matters most. I will see you in the next one.